Hello everyone, this is episode 3 in a series about problems we need to avoid when we read statistics in the news, or indeed whenever we encounter statistics. In previous episodes we looked at Simpson's paradox, then data dredging. Both of those phenomena caused the problem that we might collect some observations but then reach a wrong conclusion about the underlying cause of those observations. In this episode, I will describe a third big problem that can lead us astray, namely regression to the mean. But I also want to compare this with the first two, so let's recap. In episode 1 on Simpson's paradox, there is something called a confounding variable, which we overlook. And this confounding variable, or the thing we overlook, causes us to wrongly believe that the effect of some action is the reverse of what the action actually does. My example was that we might come to believe that medicine makes men sick, overlooking the fact that the taking of the medicine and the later sickness were in fact both caused by pre-existing poor health. And in fact, the medicine, assuming for the sake of argument that it is a good medicine, was actually causing the poor health of the people taking it to improve a bit. In episode 2 on data dredging, we have a different situation. Because here there is an action which actually has no effect, and we're not worrying about wrongly identifying the reverse of the true effect. Instead, we're worried about wrongly concluding that there is some effect at all. This can happen if, for some reason, observations are thrown away which don't show a significant effect, until, by chance, some observation does pass some test for statistical significance. And if only that result is reported, then a conclusion might be wrongly reached that an effect exists, which in reality does not exist. Now this episode, number 3, is on a phenomenon called regression to the mean, or the regression effect. To explain what this is, I'll give no fewer than 5 examples where it might be important. After that, we can give a definition of the problem based on the common feature in all of these examples. Example 1. A sportsman, so in my example this is an opening batsman in a cricket team, experiences a streak of bad results. So, annoyed because he has suffered so many poor scores in a row, he goes out and buys himself a new cricket bat. In the next few matches, his results are better. In fact, they're close to his usual average, and he credits this substantial improvement to the amazing quality of the new bat. Example 2. A woman with backache visits an acupuncturist, and afterwards her backache improves. Say the next day, or in the next few days, she finds it improves. She then goes out and tells everyone who will listen that acupuncture is a splendid therapy, and she recommends it to all of her friends. Example 3. Following a year in which there is an unusually bad spate of traffic collisions on a stretch of road, speed cameras are installed. In the next year, there are fewer traffic collisions, and as a result, the delighted county council awards a generous bonus to its director of road safety. Example 4. A young man is feeling depressed. He visits a psychoanalyst for a therapy session, and the next week he feels better. This persuades him. It's a great idea to sign up for a long, expensive course of psychoanalysis. And then example 5. This is a historical real-world example. An aircraft flight instructor observes that when trainees have a bad session, and he shouts at them afterwards, they almost always perform better in the next session. He also notes that when he praises students after a good session, they typically do worse the next time anyway. The instructor develops a belief that punishment is a good motivation and congratulation is a poor motivation, and he recommends training students like this. You might sense that I am pretty gloomy as I read you these examples. But why am I so gloomy? After all, it is conceivable in each case the action really did have the benefit which the people in the story believed it to have. Maybe the new cricket bat was better, the medical treatments were effective, etc. The problem is, it is also believable, and I would personally say very likely, that in every example the action had no effect at all, and the observed benefit came about by chance. And so, in fact, the people all developed a depressing superstitious belief in the benefit of something which actually is mumbo-jumbo. For example, you can imagine that the backache is only an occasional problem for the woman in example 2, and when she gets it, it only lasts a few days, and because it's only an occasional problem, she's unlikely to get it again for a while afterwards. Hence, since she books an acupuncturist treatment after she has an unusually bad day, I would naturally expect her to be better soon afterwards, even if the acupuncture treatment had no effect. But she sees the acupuncture as the only explanation for her improvement, and tells everyone it works. The other examples have the same problem, essentially that someone has in effect waited for an unusually bad thing to happen, and then attributes any later improvement to a particular action, rather than to the situation being controlled in large part by chance. A couple more notes on these examples. First, in the case of the flight instructor, the superstition of the instructor is that shouting is a great method of teaching. This is really depressing for me to tell you, but this was his belief, and happily, in that real example, in the 1960s, a psychologist named Daniel Kahneman learned about the instructor's views and wrote an argument about why he was wrong, which we'll understand as regression to the mean. Second, even if the action in each example does have some small effect on the outcomes, either slightly good or slightly bad, rather than absolutely no effect, the random element in the situation might be big enough to overwhelm the effect of the action, so we can't tell what the effect is. For example, the new cricket bat might actually be slightly worse than the old one, and we'd never know if we didn't think of doing more tests. Third, it has been pointed out that some county councils have a policy that speed cameras may only be installed on stretches of roads after those stretches have had an unusually bad run of traffic accidents. Now, this has the effect of rigging the statistics, so that if the county council reports the previous year before installation and the next year, it does tend to produce the result, by regression to the mean, that the speed cameras seem to have had a big benefit. I'm not saying they haven't had some benefit. I'm saying that the policy rigs the statistics to make them look better than they actually are. Now, regression to the mean, I wanted to compare with these other phenomena. It's different from data dredging, but there's enough similarity to make it worth comparing. Remember, in data dredging, we are worried about people throwing away observations until an unusually extreme and statistically significant one is found. In the examples of regression to the mean, you see no one was obviously throwing away data. Instead, that's why it's different. Instead, the problem is that the situation is arranged so that we don't start collecting data until we have encountered an initial baseline situation which is unusually extreme. For example, in the case of the cricket player, he didn't even consider getting a new bat until after a streak of bad results. Data dredging would be somewhat different. You would have to imagine a different situation with better record keeping but equally careless analysis. You might imagine the cricket player changed bats in the middle of each month, and then analysed the results for each month before and after by data dredging. Then, if he spotted one month in which the change of bat happened at the same time as an improvement in his batting average, he might wrongly generalise to claim that the new bat always causes an improvement in his batting, as a general rule. He might do that if he, by data dredging, threw away the non-significant results. So this second case would be more obviously shown to be wrong, because we could easily look at the other data before throwing it out and demonstrate that there wasn't always an improvement. Okay, once you know about regression to the mean, it's pretty easy to find examples of it everywhere. A famous one is that great movies are usually followed by disappointing sequels, and you can think of many more. Another amusing example of regression to the mean is in drug trials for treating moderate diseases, like high blood pressure. In such trials, it may be that patients are recruited specifically because they have very high blood pressure at some point in time, and then they're either given a new drug or put in a control group and given a placebo pill with no active pharmaceutical ingredient. Because of regression to the mean, some researchers have marveled at the improvement observed not just in the treated group, but also in the control group, and they've attributed this variously to the wonderful psychological benefit of having been given a pill, or indeed what they think of as the marvelous benefits of having taken part in a research project with splendid researchers to talk to, such as the investigators themselves. I think essentially the same misinterpretation happened in this entertaining but misguided paper on what they call the benefits of the placebo effect in the treatment of canine epilepsy. So this is canines are dogs, by the way. This is pretty funny, because if you take the common definition of the placebo effect as a real psychological benefit which comes from believing that you're being treated with some marvelous medicine, then you wouldn't expect dogs with epilepsy to get better after being given a sugar pill, because dogs could not possibly have the faith in modern medicine which might benefit a human patient. The paper then implies that there is a therapeutic effect, they say, which comes maybe from the owner's expectation of a successful treatment, perhaps causing the owners to perceive an improvement in their dogs, the so-called perceived placebo effect. That is, despite the fact that owners weren't told if the treatment was real or placebo. Nonetheless, the fact that it might be real might have caused them to perceive an improvement in the health of their dogs. Actually, this paper does include a paragraph on how this so-called placebo effect might occur by regression to the mean. This is an unusually sensible paragraph compared to the rest of the paper, and it looks to me like it was a reviewer comment that was pasted in, because it contradicts much of the rest of the tone of the paper, which talks about a therapeutic effect of the placebo treatment in dogs. Anyway, the idea in the sensible paragraph is that only owners whose dogs are unusually sick will enter their pets in a medical trial, and hence even the control group might get a bit better if their unusually poor initial health was partly a random variation, and hence tend to get a bit better during the trial. Anyway, you'll be happy to know, I imagine, that the dogs treated with real drugs did get a slightly better improvement than the ones given a placebo treatment. So, seemingly, some drugs for treating dogs do work. A bit. Anyway, regression to the mean, together with Simpson's paradox and data dredging, make up what I can think of as the big three problems in data analysis. It's possible to go onwards and look at mathematical methods to avoid being misled by these big three, but the first step is certainly to know they exist, and to know what they look like. I hope this video provides a useful explanation of those things, and so have a great day, and do return for more statistics notes in the future.